Imagine creating the world's most advanced chips without controlling the machine that makes them. That's the reality behind today's semiconductor industry. Apple, Nvidia, Intel, AMD, Qualcomm, and Samsung compete fiercely. Every new generation of chips is a race. Yet before any of them can build the next generation, they all depend on the same company. Not because they want to, because they don't really have another choice. Most people think ASML's advantage comes from one incredible piece of equipment, but that's only part of the story. Building the machine wasn't the breakthrough. Getting thousands of impossible things to work together was. ASML didn't create every piece of that technology alone. The world's most advanced optics, the world's most powerful light source, the world's most precise control systems, none of them belong to ASML. No company is the best at every technology. That's exactly why ASML became so valuable. Its job wasn't to invent everything. It was to integrate everything. To understand why ASML became so important, you first have to understand the problem it solved. The semiconductor industry has always chased the same goal: more computing power in less space. But making chips smaller isn't as simple as shrinking an image. Those tiny patterns have to be physically printed onto silicon with extraordinary precision. And eventually, the old methods reached their limits. The industry needed an entirely new way to manufacture chips, a technology capable of creating structures that previous manufacturing methods couldn't reach. That challenge eventually led to EUV lithography, and solving it required a machine unlike anything the world had built before. That breakthrough became ASML's defining achievement. So why doesn't another company just build a competing machine? The world's biggest technology companies have the money and resources to develop an alternative. They have some of the best engineers on the planet, and they have every reason to challenge ASML's position. But this is where the problem becomes much deeper, because the hardest part isn't building the machine. It's building the experience behind the machine. Millions of tiny decisions, all of them refined over decades. How every component interacts, how reliability improves, how problems are solved only after years of real-world use. Experience isn't something you order, it's something you accumulate. Even if another company worked with the same suppliers, it wouldn't inherit the accumulated knowledge from joint development, the manufacturing lessons, or the trust built through close collaboration with leading chip makers. ASML's position today might seem inevitable, but it wasn't. For a long time, ASML wasn't the company people expected to win. When the semiconductor industry was searching for the next generation of chip manufacturing, Japanese companies like Nikon and Canon were already major players in the semiconductor lithography market. But the race toward EUV was different. It required a commitment that few companies were willing to make. At the time, success wasn't guaranteed. ASML continued investing anyway. Developing EUV meant solving problems that had never existed before, from creating powerful light sources to controlling mirrors with extraordinary precision. Many companies moved in other directions because the technology was still far from practical. And when EUV finally became possible, ASML was the company that had already built the experience, partnerships, and technology needed to deliver it. Replacing ASML wouldn't mean building another machine. It would mean replaying decades of engineering, collaboration, and learning. That's the part no one has figured out. And that's why ASML matters today. Not because every chip depends on the company. Most chips around the world are still made without EUV. But the most advanced chips, the ones powering AI, high-performance computing, and the next generation of technology, depend on pushing manufacturing further than ever before. The company doesn't compete with chip makers, it enables them. Every breakthrough chip begins long before it's designed. It begins with the technology that makes it possible. And today, no one else comes close.